Okay, so we are in the last unit, bonding, and that's chapters 8, 9, 11, and 12. No, 8, 9, 12, and 13. Now, before you think, oh my gosh, that's 4 chapters, actually, it's not that much. We're taking little bits out of it. There's really only 3 key concepts here, and that is 1, doing Lewis dot structures, 2, identifying the hybridization on the central atom, and 3, developing the shape of the molecule. So really those 3 things, and we take bits. No math, no algebra, it's all descriptive, so some of you would really like this. So we're going to begin with Lewis dot structures. For atoms. And then after that, we'll start taking atoms and building them together to build molecules. So we got to go back and review a little bit of our quantum mechanics. So suppose we've got magnesium, and we want to do the electron configuration for magnesium. So we go to our periodic table, and when we look at magnesium, it's element number 12, and its electron configuration would be 1s2, 1s2, 2s2, 2p6, 3s2. Now the valence electrons are all the electrons in the S and P in the outermost level. So only these electrons are considered valence because the outermost level is the third, and it's all the S and P's in the outermost level. So magnesium has 2 valence electrons. Okay? Now, Lewis dot means that we're going to represent electrons as dots, and we're only concerned about the valence electrons. So magnesium has 2 valence electrons. So what I'm going to do is I'm going to put 2 dots to represent the 2 valence electrons. Okay? That's simple. All right? How about if we did, let's say, silicon? Okay? We have to know the electron configuration of silicon. Well, silicon is 1s2, 2s2, 2p6, 3s2, 3p2. So that means silicon is going to have 4 valence electrons. Okay? So to put the dots around silicon, it's got 2 s's, so they go there. The s electrons always go on the right side. But now I've got 2 p electrons. You don't do this, okay? Remember, each electron gets its own house before you start doubling them up. If you remember back to when we did the orbital diagrams, these 2 electrons are not paired up. One is in each of the p's. So when we write them on the silicon, we put 1 there and we put 1 there. Okay? So the p's go on those 3 sides. So if we were to do, let's say, oxygen, okay, oxygen is 1s2, 2s2, 2p4. So oxygen would have 6 valence, because again, only the outermost level. So it has 2 s electrons, and it's got 4 p's. So I'd put 1, 2, 3, and then I would double it up and go there. So once again, the p's go on these 3 sides, and the s goes right there. Okay? Now, in case you have forgotten how to do the electron configurations, you can go back and review your notes. But there's something else you can do, is just look at your periodic table. Remember that big fold-out periodic table has got the electron configuration right below the element. The second thing you can do is actually literally look at the periodic table. Let me show you what I'm talking about. If you look at your periodic table, the Roman numeral tells you the number of valence electrons. So group 1A has 1 valence electron. Group 3A has 3 valence electrons. Group 4A, 4 valence electrons. 5A, 5 valence electrons. For our purposes, we stay away pretty much from the transition metals because they're a little bit trickier. So when we're doing these problems, we're sticking with the major groups, all the A groups, and not the B groups. So in our next video, I will show you how to start taking these atoms and combining them to form molecules and compounds.